Welcome back. Let's keep going with lesson 1 of Polygons. Reference page. This is meant to provide you with some sort of hints and helps for solving all sorts of different little puzzles that we're working with in our Polygons or Geometry unit. I have some notes to try to keep me on track so I can keep talking sensibly. I think I will use this diagram here as my reference to talk about all sorts of things, and I'll use these top 3 ones as my place to write down our results. That's going to be my attempt. We'll see if this works. So I'm coming back to fill in the top 3 boxes as I work with this bottom one here as my example. So don't freak out, we are going back. First of all, I hope your eyes tell you that lines A and B are what's called parallel. Railroad tracks. Those 2 lines won't ever meet. We can do a lot of math with parallel lines and trust them. They're also useful for us in the future because a lot of our shapes have parallel lines in them. Shapes like rectangles, shapes like squares. So we are working towards the future here as well. Now, since these lines are parallel, when we draw a line through them, it's called a transversal. You don't need to know that word. It's not that important. It's a line that goes through 2 other lines. It's fine. There's a lot of patterns of things that are the same when you cut a line, a transversal, through 2 parallel lines. I hope it's okay to you that whatever this angle is here, this angle here has to be the same size. I'm just going to wait for just a second. This angle here has to be the same size as this angle here. Otherwise, those 2 lines are not parallel. I often do a counterexample. I try to draw 2 lines that are not parallel as my counterexample. So let's draw this one here. And then let's try to draw exactly on this black line here, just as a double up. And then I'm going to draw again a transversal through here. They just made an announcement on the announcing thing, so I paused for a second there. Safe to say these 2 lines are not parallel with each other, and then we ran the transversal through them just as well. Arrows on the end, so they indicate that they are lines that go forever. If I try to do this labeling here, I'm sure your guts are going to tell you that angle is definitely not the same size as that angle there. Fair enough? When the lines are parallel, our brains will trust it. This has to be the same size as this one. When the lines are not parallel, our brains also go, this angle here is way bigger, this angle here is way small. They just aren't the same size, it's not going to work. So I use this as a counterexample to try to prove that you're right, this is true. That angle is absolutely the same size as that one. And then there's all kinds of other angles that end up being the same as each other too. I'll use the one that's right next door. In this one here, is it safe to say that as long as these lines are actually straight and drawn with a ruler, the angles that are opposite have to be the same size as each other? This pink dot angle should be the same as that pink dot angle. And definitely something. That X angle there should definitely be the same size as that X angle there. The official title of this one is vertically opposite angles are congruent. That's the way you say it in math land. These pink angles are called vertically opposite each other. I've taken to calling this the X angle rule, because the 2 lines kind of make the symbol X. That's what it means. So I tend to call this the X angle thing in my class, rather than they are vertically opposite. Don't you know that? That's the way I've chosen to teach it in my room. Back over here, can you see that the black line here and the black line here are also making an X angle? Which means that whatever this dot is, that one should be exactly the same as it. Whatever this dot is, this angle should also be the same as it. And so now we have 4 different angles that are the same size as each other. You don't have to draw the angle little arrow things in there. I'm just really trying to draw your eye to it. Next concept we're going to use, I'm actually going to borrow this one over here. Let's do some new colors. I've done green and pink so far. Let's do some blue. So here, safe to say that the line from A to C here is dead flat straight. I'm just going to point out that I'm going to erase this one right away. Don't write it down on your paper. If we were to start here and go all the way around, that would be a full 360 degrees. Which means if we're going to do a straight line here, that's going to be half of the 360, which is 180 degrees. I won't mind labeling that one, just to be really clear. 180 degrees is halfway. And so when it gets divided into 2 pieces, like the line OB did, then we have an angle that takes us this far, and angle 1 takes us the rest of the way. But we do know those 2 segments together have to make 180. They have to get us halfway around the circle. And so we can do some math on this. If we know how big angle 2 is, we can subtract out of 180 to figure out how big angle 1 is. These are called, for the record, supplementary angles, which means they add to 180 degrees together. That's the word for it. 2 colors. Blue. What should I do? This angle here, together with this angle here, should make 180 degrees together. That's called supplementary. In my room, I've tended to start calling this the rainbow angle. Because if you start here and you go all the way to there, it kind of looks like you've made a rainbow. So, officially they're called supplementary in Mathland. If you don't like that word, then start calling them the rainbow angles. That works for me too. Here, can you see we were creating a rainbow? And so, whatever this pink one is, this blue one together with it should make 180 degrees here. Pink together with blue makes the full 180. And we can play the same game this way. You might honestly be better turning your page. I don't think I'm going to try to turn my page. It's going to make you all go cross-eyed. But this line here also is straight, which means this should also be a full rainbow here. Which means, again, whatever the pink one is, the blue one together with it should make 180. Also, if this angle is an X, from this one we know opposites also should be equal to each other. So this angle here is opposite of this one here. X is opposite of X, so they should also be twins. And the end result of all of that is, in reality, there are only 2 sizes of angle available here. There's pink-sized angles, and there are blue-sized angles. There are 1, 2, 3, 4, 5, 6, 7, 8 different angles available, but they're actually only of 2 sizes. They're either pink-sized or else they're blue-sized. You'll notice I have not put any numbers to them. That is, I'm trying to be careful not to do that, because this works no matter what size of angles you make this. Counter, quick example here in the corner. If I make parallel here, and if I draw the line through them that way, it still works. However big this one is, that one's the same. However big this one is, that one's the same. However big this one is, that one's the same. However big this one is, that one's the same. It doesn't matter what size of angle they are. If they are parallel lines and a line cutting through them, they all pair up. Basically, of the 8 angles, there's only 2 different sizes to worry about. I'm going to shut up because that's a long video already. I'm going to use this pink and blue dot stuff in the next video to help fill in the 3 different patterns up above. See you over there.